Hi everyone, this is Mrs. GA, and today we're going to learn about arc length and how to find the area of a sector. So the arc length, which we use the variable s to denote, of an arc with a measure m and a radius r is given by this formula. So again, to find the arc length, we take the measure of the arc, we divide it by 360, and then we multiply it by the circumference, 2 pi r. So notice that this is just our circumference. So what this arc length formula is giving us is essentially, imagine you laid a piece of string from A to B, and then you took that string and you measured it along a ruler. So it's actually the distance from A to B. So again, the arc length is not the angle measure of the arc, it's actually a distance. So again, here's the formula. The measure of the angle in degrees divided by 360 times 2 pi r, the circumference of the entire circle. So you do need to know two things to do this. You need to know the measure of your arc and the radius of your circle. Okay, let's see if we can use that formula for the problems in example 1. So here we're going to give our answer in terms of pi, which means that instead of plugging it into our calculator when we multiply by pi, we're actually just going to leave it with pi, but then we're also going to provide an answer rounded to the nearest hundredth. So we're going to provide what's called an exact answer and an approximate answer. So here we're asked to find the length of arc CDB. So a few things we notice from the picture. We can see that the radius of our circle is 5. And we know that since this is a diameter, it's a segment that goes through the center and it has endpoints on the circle, we know that the measure of the arc CDB is 180 degrees. It's exactly half of a circle. So now we have everything we need to use this formula we learned above. Okay, so the arc length, which remember is denoted by S, equals m, which is 180, divided by 360, times 2 times pi times r, which is 5. So first they asked us to provide an answer in terms of pi, which means we'll still multiply 180 times 2 times 5, and then we'll divide it by 360, but we'll leave pi as part of our answer. So just remember, when we have a fraction times whole numbers, these get multiplied to the numerator. So again, 180 times 2 times 5 divided by 360 is 5. So S equals 5 pi, 5 times pi. And that would be our exact answer for the arc length of CDB. But we can also give an answer that's rounded to nearest hundredths by now plugging this into our scientific calculator. And we're going to use that pi button, so you just type in 5 pi, and that gives us the decimal approximation of 15.71. Again, here they asked us to round to the nearest hundredths. So what my calculator said was 15.7079. To round to the nearest hundredth, you look at this, and this rounds up to a 1. Okay, let's try part B. So here they would like us to find the measure of arc. Oops, looks like there's a little typo here. Let's change this to arc AB. So here we can see that we have M, which is 60 degrees, and we have our radius, which is 9. So we have everything we need for that formula. So again, we do S equals 60 over 360 times 2 times pi times r, which is 9. So again, we'll leave our first answer with pi, so we'll multiply everything else out. And we get 3 pi. So that would be our exact answer. And then to get a decimal approximation, we simply plug 3 pi into our scientific calculator, and we get a decimal approximation of 9.42 if you round to the nearest hundredths. All right, that is all for arc length. So now we're going to move on to the area of a sector. So a sector of a circle is a region bound by 2 radii and their intercepted arc. So I always think of a sector as just simply a slice of pie. Or maybe a slice of pizza. That's kind of what it looks like. So this shaded area would be a sector. So there is a formula that allows us to find the area of this sector. And the formula is right here. So it says the area of a sector with a central angle of m degrees. So remember, the central angle would, in this picture above, would be right here, of m degrees, of a circle with a radius of r, is given by, so we take our m value, we divide it by 360 again, but this time we multiply by pi r squared. And remember, pi r squared is that area formula. So we need two things to find the area of any sector. We need the measure of the central angle formed for the sector, and we need the radius of our circle. Okay, let's look at example 1. Here we're asked to find the area of sector POQ. And we're going to use the shaded region of POQ. Leave your answer in terms of pi, and then we're going to do another answer that's rounded to the nearest hundredths. So again, we're using the shaded region. So here we can see that the measure of the central angle was given. It's 210 degrees, and we can see that the radius is 3. So we have everything we need for our formula. So we do m divided by 360 times pi times our radius squared. So the first time when we leave it in terms of pi, I'm going to take 3 squared, multiply it by 210, and then divide by 360. So we get an area of 5.25 pi inches squared. So this is what we would call an exact answer because we don't need to round. So by leaving pi in there, we do need to round. But we could get a decimal approximation. So if you actually plug in 5.25 pi into your scientific calculator, you would get a decimal approximation of 16.49, if you round to the nearest hundredths, inches squared. Okay, let's look down at example 2. So this one says a beam, it was supposed to say a beam, like a beam of light, from a lighthouse is visible for a distance of 5 miles. To the nearest square mile, what is the area covered by the beam as it sweeps in an arc of 150 degrees? So let's imagine this. This is our lighthouse from a bird's eye view. So I'm looking down at the lighthouse. So we know that the lighthouse can send out a beam like this, a beam of light. And it says that that beam is visible for 5 miles. And then imagine, right, in a lighthouse, they kind of swivel around the beam so it can reach more space. So this beam sweeps in an arc of 150 degrees. So it does something like this. So this would still be 5 miles. And then this, from here to here, is 150 degrees. They would like to know the area to the nearest square mile that is covered by the beam. So they essentially want to know the area of this sector. Because if you imagine the beam swung all the way around 360, this would make a circle. So here we can see our radius is 5, our central angle is 150, and we have everything we need for our formula. So we simply do m divided by 360 times pi times our radius squared. So here we're going to plug in everything including the pi, and we're going to get an approximation to the nearest square mile. And this would give us a decimal approximation. Well, if we round to the nearest square mile, it'd be 33 miles squared. Again, what my calculator shows is 32.724, so on. So if we round it to the nearest whole number, it becomes 33. One last thing, I do want to make sure that you are actually trying these calculations with your own calculator. I know it seems like an easy enough step to skip, but if you're not practicing it with your calculator, you may not know how to do it when we get around to the test or quiz. So make sure you're actually practicing plugging these things into your calculator and make sure you're getting the same answers that I'm getting. Okay, that is all for today's video. Thank you so much for watching.